massive space rock impact could have instantly created the moon. Computer simulations of giant space rock impacts suggest an alternative instant origin for the Earth-Moon system. The simulation screenshot shows a stream of ejected material created by a giant impact coalesces into the body that would become the moon. The image by Dr. Jacob Kegerreis. The giant impact may have rapidly placed the moon into orbit around Earth rather than creating a disk of debris from which the moon gradually formed over time, new research suggests. A highly detailed computer simulation created by Durham University's Institute for Computational Cosmology revealed this alternative origin story for Earth's lunar companion, our moon. This new, aptly named immediate satellite scenario would mean the proto-moon was less molten during its formation and suggests much of the moon formed immediately after a giant impact on our Earth. This more rapid formation theory would also suggest a different internal composition for the moon that could offer an explanation for some of the curious Earth-like characteristics seen in lunar samples. The moon is thought to have formed around 4.5 billion years ago when Earth was hit by an object from space roughly the size of Mars that scientists have called Theia. It was previously theorized that this impact threw up a field of debris from which the moon gradually formed. A consequence of this would have been that the moon was mainly created by the material provided by Theia as opposed to material from our Earth. This idea was challenged when it was discovered that lunar rocks seem to have a composition that's very, very similar to the mantle of our Earth. The high-resolution results obtained with the impressive computing power of the die-rack memory intensive service called COSMA, located at Durham University in England, showed an outer layer of the moon rich in material originating from our Earth. This formation route could help explain the similarity in isotopic composition between the lunar rocks returned by the Apollo astronauts and Earth's mantle, research co-author and University of Durham physicist Vincent Eck said in a statement. There may also be observable consequences for the thickness of the lunar crust, which would allow us to pin down further the type of collision that took place. The team's simulation took into account hundreds of different impact scenarios that varied the angle and speed of Theia collision, in addition to varying the masses and spins of two colliding bodies. It also shows that a large natural satellite like the still-forming moon could survive in close orbit around our Earth. It was previously thought that a rapidly forming large body close to Earth would be ripped apart by tidal forces emerging from our planet's gravitational influence, thus favoring a slow creation process for the moon. These new simulations suggest that such a body could not only survive tidal forces, but could actually be pushed to a higher orbit, delivering it from the threat of future destruction by such forces. We went into the project not knowing exactly what the outcome of these high-resolution simulations would be, so on top of the big eye-opener that standard resolutions can give you wrong answers, it was extra exciting that the new results could include a tantalizing moon-like satellite in orbit. Co-author and NASA Ames scientist Jacob Kegerreis said in the team statement, "This opens up a whole new range of possibilities, starting places for the moon's evolution." The team's research was published yesterday, October 4th, in the Astrophysical Journal Letters, and this is on space.com. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.